Hey everyone, welcome back to another lesson of pre-algebra. So last lesson we went over how to add and subtract radicals. So today we're going to be learning how to multiply and divide radicals. So starting off with multiplication, we're going to list some of the basic rules and do some practice problems. So the first problem I have is times radical 6 and equals what? So when we were adding and subtracting radicals, I said that you can't add or subtract them unless they have the same radicand. But in this case, with multiplying and dividing, it doesn't matter what radicals you work with. You can multiply and divide any sort of radicals. So with that being said, how do you do it? So multiplying is very simple. You just have to multiply whatever number is inside the radical with the other number. So in this case, we would multiply 2 times 6. So that's 2 times 6 is to put it under a radical. So our final answer would be radical 12. And since radical 12 can be simplified, we're going to do just that. So radical 12 can be broken down into radical 3 times 4. And just like how we simplified in our last lesson, we're going to break those into their own radicals. And we see that we have a perfect square, which is 4. So it could be simplified down into 2 radical 3, and that would be our final answer. So there's nothing like complicated about it, and there's no surprises, and it's not as difficult as adding and subtracting, as you can multiply any kind of radicals. So let's do another one. Let's do radical 3 times radical 15. Now first we're going to check that these radicals are fully simplified because it's easier to work with smaller numbers. And if you look at radical 3 and radical 15, there's no perfect squares that you can divide them up into, so then we're going to continue on with multiplication. So we just multiply whatever's inside the radical, which is 3 times 15, and we know that's 45. So our final answer, well, not our final answer, but our answer is going to be radical 45, and we have to check that it's fully simplified, which it's not, because it's divisible by perfect squares. So the first thing we're going to do is brainstorm what we could turn radical 45 into. And there's many different options, like 3 times 15, which so unlike adding and subtracting, we don't have to focus on whether they have a similar radical or if they share anything to be able to multiply. We just go straight into multiplying. So when they have coefficients, the coefficients multiply with each other, and the radicals multiply with each other. So we do multiplication essentially 2 different times. What I mean by this is we do the coefficients first, which is 2 times 5, and we know that's 10. And then we multiply whatever is inside the radical, which is 3 times 2, and we know that's equal to 6. Now we have to double check and make sure that 10 radical 6 is fully simplified, and 6 can only be broken down into factors of 3 times 2 or 6 times 1, and none of those can be simplified down even more, so our final answer is going to be 10 radical 6. Sorry. Okay, now our next problem is going to be 3 radical 8 times 4 radical 5. So the first thing you always want to do is check if any of the factors can be simplified down beforehand before getting the actual solution to make numbers smaller. And if I take a look at this, we know that this radical can be simplified down because radical 8 can be split up into radical 4 and radical 2. So we're going to do just that first. And we go through the simplifying process, break down radical 4 into just 2. 3 times 2 is equal to 6 radical 2. So our new equation is 6 radical 2 times 4 radical 5. Now we do the coefficients and then the radicals. So 6 times 4 is equal to 24, and inside the radical we have 2 times 5, which is equal to 10. So 24 radical 10 is our final answer because radical 10 cannot be simplified into anything further. Now we're going to do 3 times radical 12 times radical 6. So if I take a look at this, we know that we can simplify down radical 12 even further because it's equal to 4 times 3. So if we do 4 times 3 inside the radical, give them their own little houses, and then radical 4 can be simplified down into 2 because it's a perfect square, and 2 times 3 is equal to 6, and so we get 6 radical 3 times. So now we're going to multiply the coefficients, which is just 6 times 1, and we assume the 1 because there's nothing written in front of the radical 6. So 6 times 1 is equal to 6, and then 3 times 6 is equal to 18. So our final answer would be 16 if it was simplified all the way, which it is not. Radical 18 can be split up into 9 times 2, and we know that 9 is a perfect square. So let's take this on to the next page. I have 6 radical 18. So 6 times radical 18 can be broken up into 9 times 2. And 9 is a perfect square. So we're going to take 3 from that. So we do 3 times 6, which is 18 radical 2. And that's our final answer. Our next problem is 3 radical 2 times radical 10. So there's no radicals that can be simplified down here. So we're going to go straight into multiplying the coefficients, which is 3 just 3. And then 2 times 10, which is 20. And now radical 20 can be simplified down even further because it is a multiple of 4. So we're going to take 3 times 20, radical 20, and split it up into 4 times 5. And 4 is a perfect square, so it can be directly turned into just 2, and 2 times 3 is 6. And then, so our final answer is 6 radical 5. Next we have 4 radical 3 times 3 radical 6. And first we double check to make sure that the factors are simplified down first, and radical 3 and radical 6 are both at its simplest form, so we move on to the coefficients, which is 4 and 3. 4 times 3 is 12, and then we just multiply whatever's inside to get 18. And just like a problem that we did before, radical 18 can be simplified down into 9 times 2. And if we do 9 times 2 into their own radicals, we can get rid of the radical 9 because it's a perfect square. So it's going to turn into 3, and then we do 3 times 12, which is 36, and then put the radical to get 36 times radical 2. Next we have 2 radical 5 times 7 radical 3. So both of these numbers are in their simplest form, so we multiply the coefficients, which is 2 times 7, and that's 14, and then the radicals, which is 5 times 3, and that's 15. And 15 is just 5 times 3, or 15 times 1, and none of those factors can be simplified down even further, so 14 times radical 15 is our final answer. Next we have a negative number, negative 4 times radical 6 times 7 times radical 15. So 15 and 6 are both radicals that cannot be simplified down, so we multiply the coefficients, first instead. So we have a negative, we have one of the numbers that are negative and the other is positive. And negative times positive is always negative, so I'm going to start out by writing the negative in first. And then you do 4 times 7, which is 28. And then we multiply the radicals, which is 6 times 15. And if you don't know that from the top of your head, you can just plug it in a calculator to get 90. So right now we have negative 28 times radical 90. And now you might not know exactly what factors 90 can be split up into because it's such a big number. So instead of looking for perfect squares, we're just going to look for factors. And the most basic factor that anyone would probably think of is 9 times 10. So we're going to work with that. And we see that 9 in fact is a perfect square, so it makes our life a lot easier. Split it up into their own radicals to get radical 9, which is equal to 3. And then you do 3 times negative 28 and plug that into 84 radical 10. And 10, even though 10 is not a prime number, the only factors it has is 2, 5, 1, and 10, and none of those can be simplified down. So this is our final answer. Now we're going to play with the distributive property a little bit, which I went over in a previous lesson. So make sure to check those out if you don't know how to use the distributive property. So we have 2 radical 5 parentheses radical 6 plus 2. And according to the distributive property, we're going to multiply 2 radical 5 to both radical 6. We add them together because the operation in the middle is addition. So if I expand that out, we get 2 radical 5 times radical 6 plus 2 radical 5 times 2. So first we're going to work with the first section of this expression. And so that's 2 radical 5 times radical 6. And we're going to simplify this how we have been doing any other problem, which is 2 times 1. And then we do the stuff inside the radicals, which is 5 times 6, and that's 30. And now we do the other part of the addition, which is 2 radical 5 times 2. And since 2 it stands alone, treat it just as another coefficient. So we do 2 times 2, which is 4, and then stick. So now we have to add these together. And if you look at it, it's not actually possible, because if you remember from our previous lesson about adding and subtracting radicals, the radicand have to be the same. And so unlike multiplication, the things inside the radicand actually, we can't add it unless it's the same number. And 30 can be simplified down into 5 times 6, but there is no perfect square that we can take out of the radical. So this is just the final expression that we are left with. Let's do a similar problem. Radical 6 times radical 3 plus radical 12. So because of the distributive property, we're going to do radical 6 times radical 3 plus radical 6 times radical 12. But before I do that, I'm noticing that radical 12 can be simplified down into something else, so we're going to do that first. So radical 12, we're going to do here, radical 12 is 4 times 3. 4 is a perfect square, so we take it out to make a 2. And so we're left with 2 radical 3. And now we distribute. Radical 6 times radical 3 plus radical 6 times 2. And if we radical 3, we get radical 18. and then we do the coefficients of the second part of the equation, 2 times 1, which is 2, and then radical 6 times radical 3, which is 2 radical 18. Here we have the same radicand, so we are able to add. So we get 3 radical 18 because there is an imaginary number 1 right here. 3 radical 18 can be simplified into a smaller number because radical 18 can be times 2. So we're going to split those up into their own radicals to get radical 9, which is equal to 3. So 3 times 3 is equal to 9, and stick on the radical 2 from before to get our final answer of 9 radical 2. So I think through these problems, I hoped of multiplying radicals. So now we're going to move on into dividing radicals. So our first problem, I'm going to start off with something fairly easy. We're going to do the radical 18 divided by 2. And you can actually just simplify the fraction first to make this a lot easier. And so if you do 18 divided by 2, you get radical 9, which we know from the top overhead is just 3. Now there's many different ways to approach division. Like you could have split this up into radical 18, but the process would be much longer and much more complex. So it's preferred not to do it this way if the fraction can be simplified down first. The next is 64 over 16. Now, the first thing you should notice is that 64 and 16 are both perfect squares. So a rule of division when you're working with radicals is that you can split the radical up into the numerator and the denominator. So these two expressions are equal to each other. So now we just have radical 64 and radical 16, which are both perfect squares. So we can simplify that down into 8 over 4. And 8 divided by 4 is equal to 2. So that's our final answer. Now how about something like 12 over 4? We're going to simplify the fraction, which is 12 divided by 4, which is 3. So we just get that as our answer. But let's try a different solving method, which is the one that we just did previously. That would get us to radical 12 over 2, because radical 4 can be simplified right into 2. And then if you remember, 12 is 4 times 3, which would equal 2 radical 3 over 2, and then you cancel out the 2 to get radical 3. But that, of course, as you can see, is a much longer process. So if you can simplify the fraction beforehand, make sure to do that before. Now let's do 15 over 20. So we can simplify the fraction because the numerator and denominator are both divisible by 5. So that gets us to 3 over 4. Now if we split those up into their own radicals, we see that we have a perfect square in the denominator. So we get radical 3 over 2. And that's our final answer. Now we have 2 radical 14 over 4 radical 2. So the first thing I'm going to do is simplify the coefficients, because you can think of this as 2/4 times radical 14 over radical 2. The coefficients and radicals can be separated. So if we simplify that, we get 1, or you don't even have to write the 1, which I mentioned before, so you just get radical 14 over 2 radical 2. Now we can actually simplify this down even further. because radical 14 is divisible by 2. So what we would do is divide radical 2, or you can rationalize the denominator and multiply by 2. And because we haven't gone over rationalizing the denominator, which is an important skill, we're going to go over that right now. So a radical can't be in the denominator because that makes it a irrational number. So to get rid of the radical, we have to multiply by radical 2. And we have to do this to both the numerator and the denominator, or else it wouldn't make sense, because doing this to both the top and bottom is just like multiplying by 1. So if we do this, 2 times radical 2 times radical 2 gets rid of the radical, and that's just 2 radical 4, or 2 times 2, so we get 4. And then 14 radical 2 is radical 28. And with radical 28, we can split that up into 4 times 7, which is 2 radical 7 over 4. So we can simplify down the 2 and 4 into 1 over 2, so we get radical 7 over 2 as our final answer. Now that might be confusing to a lot of people, so I'm going to work with a easier number. So 6 radical 7. So rationalizing the denominator must be done because radicals can't stay in the denominator, just as how 0 can't be in the denominator. So we're going to get rid of the radical 7, we're going to have to multiply it by itself so that it turns into an integer. So we do radical 7, and remember we have to do it to both the top and the bottom because it has to be multiplying by 1, because that would make it the same number. Multiplying by a different number would result in a whole different number than we started off with before, which ruins the whole point of the problem. So we got 6 radical 7 and 7 from that, and that's our final answer. Because there's no radical in the denominator, so it can be the answer. Now let's do 2 radical 3 over radical 24. So we can simplify the denominator before rationalizing it. So we got 2 radical 3 over 4 times 6, and we can take out the 4 to be 2 radical 6. Now we can cancel out the 2's, and we end up with 3 over 6. And we know that's equal to 1/2. But if you split this up, we still have radical 2 in the denominator. So we multiply by radical 2 over 2 to get radical 2 over 2. And that's the final answer. Next we have 50 over 2. And 50 can be broken down into 5 times 10, or just 5 times 5 times 2. Or you could have just done 25 times 2, which I'm realizing now. And so you take out the 5, and that's your final answer because there's no radical in the denominator. How about, let's do 26 over 18. So the first thing we're going to do is simplify the fraction inside of the radical to make this a simpler. So if you divide the top and bottom by 2, you get 13 over 9. And then you have to separate them into their own radicals, and 9 is a perfect square, so we just get radical 13 over 3. The last problem I have for today is 5 radical 8 over 7 radical 2. So first we're going to simplify the radical 8 break it down into 4 times 2, and then over 7 times 7 times radical 2. So we take out the 4 and we get 2, so 2 times 5 is 10, and then we just have 7 radical 2. And like I mentioned before, there cannot be radicals in the denominator, so to simplify this, we're going to multiply both the top and bottom by radical 2, and that would get the radical 2 out of the denominator. This is just like multiplying, so it doesn't affect the actual problem. So 7 radical 2 times radical 2 is equal to 7 times 2, which is 14. And then 10 radical 2 times 2, which is 20. And you can simplify this down even further because both are divisible by 2. So 20 divided by 2 is 10, and 14 divided by 2 is 7. So our final answer to this problem is 10 over 7. So I hope everyone understands how to multiply and divide radicals now. As you can see, it's much different from addition and subtraction, but it can also be easier in some ways because you can sort of radicals.